So we are in this part, or for this part of work, we will be applying certain principles that we discussed earlier. Okay. So let's start with the frequency.
So we will equate here to F1, frequency 1. This is 2. So frequency 3, frequency 4, and frequency 5. So using the diagonal approach that we used to do the addition to get this one. Frequency 1 plus 2 will give us 28, alright?
So here we are trying to find F1. So just do group like terms. So F1 will be equal to 28 and 17, which is 11. So here we have 11.
So the thing is, you cannot go like chronologically. You have to run somewhere to come and fill it up. And the principle for cumulative frequency learning that says the first frequency is the same as this one. Okay, so here also be
So as we are saying, we can also use this one to help us find the F3. Now, what we are going to do is that if F3 is equal to 28% of 20% of the relative frequency, we know that when we take the whole frequency is 120, it means that we can equate the 120 to 100. Do we get it? The whole 120, because at the end of the day here it is 100. So this one equals this one equals this. So it means that F3 equals 20, 120 will be equal to 100. Here we can do, yes. So it means F3 times 100, this one will go here, equals 120 times what? 20. Then we make this the subject. It means that F3 will be equal to 120 times 20 all over 100. Can just cancel. So F3 will be equal to what? I hope we had the same value. Okay. So F3 will be 24. Okay. We can also use this to get the F5. We know that when you take the relative frequency proportion, the total is 1.0. So we can also equate to the fact that F5 is equal to 0.15. 120 will be equal to 1. Do we get it? This is the total value of the relative frequency proportion. And this is the total frequency. So this equals this. Whilst this one to correspond to this. So we are using these parameters to get F5. So we just cross multiply like what we did. So this time we know that it's the same as F5 equals 0.15 times 120. What is it? So we are going to get 18. I hope we had the same value.
Yes.
Okay. So 18. So with this, F4, okay.
The easiest one.
Okay.
So we know that this frequency added up will give us 120. So F1 plus.
So write it down.
plus F5 will give us 120. We'll put in the value. 11 plus 7.
24 plus F plus 18.
Equals 120. So we'll do the math. I'm not a mathematician, so we just do it. So therefore F4 equals 50 for 2000.
So with this one, we can use whether the diagonal of vector to solve it. So we know that we can use this, we can add this, and this, we'll get this one. Or better still, you can just add 28 plus 24. It's going to give you the same value. So 52 plus 50 will be 102. Then this one will give you 120. 102, 120. And even with this one, we know we can apply the rule, the principle that when it comes to the CF more than, it's the same as the CF less than the last number. So this is the last, so it's the same as this one.
So continuing here, we start from the bottom. So we also know that CF more than is the same as the last frequency. So here will be 18. Then we'll use the diagonal addition. You will add diagonal from the bottom. So this plus this give us CF more than 4. So 18 plus 50 give us 68. 68 plus. So 68 plus 84 give us 88. The 92 plus 17. Give us 109.
We had the same value, right?
Yes. Is that the first CF more than is the same as the total frequency of the last CF less than. Alright. And we also know that CF more than the last one is the same as the last frequency. So for that one, you add from the bottom diagonally to the top. So the last one is 18, so we put the 18 here. 18 plus 50 will give us 68. 68 plus 24, 92. 92 plus 70 will give us 109. Understood? Yes.
So here, this is the relative frequency percentage. You know that when you in percentage, the total is 100. So it means that you will pick the frequency, you divide by the total frequency. So each frequency divided by the total frequency times 100. So the first one will be 11 over 120 times 100. Okay, sorry. So 11 over 120 times 100. 9.1. Okay. Then the second one You pick the 17 divided by the 120 times 100. Okay, so the same applies to this. 50 over 120 times 100. And the last one is 18 over 120 times 100. Okay. So with this one, we've been able to complete up to the relative frequency, the percentage. When it comes to relative frequency proportion, the total proportion is 1. So it means that whatever you get, when you add up, you should get 1. But we don't write. And it's either they don't write or they write it for you. We are not supposed to even write it. So for relative frequency proportion, the same way, you pick the total frequency. We take each frequency, you divide it by the total frequency. That's so it will be 11 over 120. So each frequency divided by the total. 0 point.
So it's the same approach we used in doing the percentage, just that you don't multiply by 100. It's the same approach.
Yeah.
So if you have done the RF already, RFP should be very easy for you to do.
Okay, so these are the values. Here, they've given you already the F5. So these are the values for relative frequency proportion. Then we come to the cumulative percentage. So, this is the
So we are going to use the diagonal abaga we use for the CF model exercise. So the first one, So the first ratio percentage will be the RF percentage.
we just be adding. So we are just adding.
It's 5.01.
5.01. Then 100. So we are done with the table.
So from what we see is, what is the modal SPO? 91 to 95. Do you agree? Yes. What are the mode mean? What does it mean? Great. So the next question
This
is
was for the answer is
91 to 90. The next question says, calculate the modal SPO2 using the SPO2 value using the group data mode formula.
okay.
the formula for calculating the modal class in class, where LM means lower limit, right? Lower boundary of the lower class, okay.
Of the modal class.
The modal class.
Lower boundary of the modal class. So this is the lower boundary of the modal class. So in getting the lower limit.
No, that's the lower limit of the modal class.
Okay.
Yes, so in getting the lower boundary.
You deduct 0.5 from this one.
Okay, so by defining it, the LM is the lower boundary of the modal class, which is 90.5. For you to get, you need to subtract 0.5 from the lower limit. Then the F1 is the frequency of the modal class. So the frequency of the modal class is what? 50. Then the F0 is the frequency before the modal class. So before the modal class, that's 24. Then the F2 is the frequency after the modal class, which is 18. Then the H is the class width. And before you are supposed to subtract the lower boundary from the upper boundary. So that's our value. And it will give us
But how did you do that? Why do you have 95.5 to 90 points?
So to get the upper boundary, you add 0.5. You deduct 0.5 from 91. Give me 90.5. And then you add 0.5 to 95. Give me 95.5.
So that's what we
Yeah.
So then you use this formula to get. So the other formula is upper limit. Minus lower limit. Plus 1. So the upper limit is 95. Minus lower limit 91. Plus 1. Cos 5.
So the same approach, different approach, the same answer. So the next
You
question.
put in the values into the formula.
So we are just doing substitution. So the lower limit, we had 90.5, right? Plus the F1 is the frequency before, the frequency of the modal class, which is 50. So 50 plus minus the frequency of the modal class before, which is 24. Divided by, so we multiply the frequency of the modal class times 2, which is 2 bracket 50 minus 24 minus 18 times the 5. So let's punch it 0.90.5 plus, this one will give us 26 divided by 100. This one is
42.
42 times 5. Continue here. So 90.5 plus. So 26 to 58 times 5. So 90.5 plus, punch this one, 0.4, So we just punch the value of this one, then you multiply by the 5. You get 2.25. So therefore the answer will be 92.75, right? So it's SPO2, so to be in percentage. Are we okay?
Yes, we are correct.
That's fine.
We are moving to the next question.